We're told the expression 4.9 t squared represents the distance in meters an object falls after t seconds. A glove falls from a ski lift that is 65 meters above the ground. The graph shows the height h in meters of the glove t seconds after it falls. So that's this graph right over here. So it looks like at t0, we're at 65 meters. That's what they said. And it looks like we hit the ground a little bit more than 3.5 seconds afterwards. Fair enough. Write a function that represents the height of the glove in meters after t seconds. Well, we know what the distance it falls in after t seconds. They tell us right there. The expression 4.9 t squared represents the distance in meters an object falls. So you might be tempted to say, okay, I'll just type in 4.9 t squared. But this would not be correct, because this is the distance that the object falls, not its height. So its height would be wherever it started minus the distance it falls. So in this example, where did it start? Well, it started at a height of 65 meters, and they told us that right over here. A glove falls from a ski lift that is 65 meters above the ground. So what you would want to do is take your starting height, 65 meters, and then subtract out the distance that it has fallen. So there you hear. This is a function that represents the height h of t. And I guess if I wanted to write it as a function, I would say h of t is equal to that, to make sure that I'm not just writing an expression. H of t is equal to that. And then I have complete the table by entering the height at t equals 3 seconds. Round your answer to the nearest tenth of a meter. So just to think about what's going on, if I look at this graph at 3 seconds, it looks like we're a little bit more than 20 meters in height. And let's see if this function we created gives us that same answer. And to help us there, let me get a calculator out. And so we're talking about at 3 seconds. So let's take 3 squared. I'm just putting 3 for t here. 3 squared times 4.9 times 4.9 is equal to this. And we want to subtract that from 65. So let me just make that negative and add to that 65. And I get 20.9 meters. And that validates what we saw on the graph as well. A little bit more than 20 meters. And we're all done.